Today we're going to do two sample hypothesis tests and confidence intervals for comparing two population means. Today we will be comparing either one characteristics of two populations or two responses to two treatments. In the first case, you have two samples from two different populations. In the second case, you have two groups assigned two treatments. The examples we're going to do today are: does mean commute time for male and female work in Calgary residents differ? The one you're going to do on your own is: does talking elevate your blood pressure? The name of our test is a two-sample test for a difference in means. Our null hypothesis is going to be mu1 minus mu2 equals 0 versus our alternative mu1 minus mu2 is greater than 0, or mu1 minus mu2 is less than 0, or mu1 minus mu2 doesn't equal 0. Another way that you could write this is mu1 equals mu2 versus our alternative hypothesis where mu1 is greater than mu2, or mu1 is less than mu2, or mu1 doesn't equal mu2. That's just a different way that you can write the hypotheses. The conditions that we need to check for our hypothesis tests and confidence intervals: one, we first have to check to see that we have two independent, simple random samples. There's no link between the two samples, or the individuals were randomly assigned to treatments. Number two, the population distributions are normal, or sample sizes are large enough, or the NPPs or histograms of the sample data showed as plausible samples are drawn from a normal population. Notice the plurals there. Both samples. Or sample sizes are large, or treatment response distributions approximately normal, assessed through a normal probability plot or histogram. The test statistic T equals x bar 1 minus x bar 2 minus mu 1 minus mu 2 all over the square root of the standard deviation of the first sample squared divided by the number in the first sample plus the standard deviation of the second sample squared divided by the number in the second sample. So the name of the confidence interval is a two-sample T confidence interval. The confidence interval would be x bar 1 minus x bar 2 plus or minus T star times the square root of S, the standard deviation of the first one squared, divided by the number in the first sample, plus the standard deviation of the second one squared divided by the number in that sample. For our confidence interval, we are estimating the difference in means, mu1 and mu2. The degrees of freedom, we use the conservative rule. The degrees of freedom equals n1 minus 1 or n2 minus 2, or the calculator degrees of freedom, part of the hypothesis test / the confidence interval output. The calculator uses degrees of freedom formula found on page 549 of your textbook. There is a pooled two-sample t-test. To use this test, you must make the assumption that the standard deviation of the variance of the first sample equals the variance of the second sample. These two groups have equal variances. The standard deviation of the statistic is on the first page of the formula sheet. We always say no to the pooled option, and this is discussed on pages 559 and 561. So let's look at example 1. We're going to run a hypothesis test with an alpha equals 0.05 and construct a 95% confidence interval in the calculator. Do the results agree? So here, each person in a random samples of 247 male and 253 female working adults in Calgary, Canada, was asked how long in minutes his or her typical daily commute was. Using the accompanying summary statistics and an appropriate hypothesis test to determine if there is convincing evidence that the mean commute times for male and female working residents differ, use a significance level of 0.05. So we have our statistics for males and females here, okay? And you're going to put in your calculator those statistics and not the data. So we're going to go through and do a complete hypothesis test. So first, I'm going to label this example 1. And the name of the test is a 2-sample test for a difference in means. And on your calculator, this is a 2-sample t-test. Mu1 is going to be the mean commute for males in Calgary, and that's in minutes. And mu2 is going to be females. My null hypothesis is mu1 minus mu2 equals 0. And my alternative hypothesis is mu1 minus mu2 doesn't equal 0. And how I chose doesn't equal rather than less than or greater than, they use the word differs. Okay, so they use the word differs. And now we need our evidence. So we have x bar 1 minus x bar 2. That equals 29.6 minus 27.3, which equals 2.3, which does not equal 0. Go through our conditions. This is a random sample of males and females working. In Calgary. No reason to believe samples are not independent of one another. And our sample is large enough. N1 equals 247, which is greater than 30. N2 equals 253, which is greater than 30. Now we can go ahead and find T. We need to write our formula out. It would be x bar 1 minus x bar 2 minus mu 1 minus mu 2 all over the square root of the standard deviation of the first one squared divided by n1 plus the standard deviation of my second sample squared divided by n2. Go ahead and plug your information in. So we would have 2.3 minus 0 all over the square root of 24.3 squared all over 247 plus 24 squared over 253 And using your calculator, because we'd put this information in, our statistics in, using your calculator, you should get a t-value of 1.0646. Also, we know our alpha level is 0.05. Our degrees of freedom from our calculator are 497. Our p-value is 0.288. And here, our p-value is greater than alpha, because our p-value of 0.288 is greater than 0.05. So we fail to reject the null hypothesis. There's not convincing evidence. That the mean commute for male and female Calgary residents differs. So now let's go ahead and find our confidence interval. So we want a 95% two sample t confidence interval. To estimate mu1 minus mu2. And this is also known as a two sample t interval on your calculator. Our conditions were already checked. Our formula would be x bar 1 minus x bar 2 plus or minus t star times the square root of standard deviation of my first sample squared divided by n1 plus the standard deviation of my second sample squared divided by n2. And we know our degrees of freedom is 497. X bar 1 minus x bar 2 is 2.3 plus or minus my t star would be 1.965 times the square root of 24.3 squared all over 247 plus 24 squared all over 253 and that would give me a confidence interval of negative 1.945 to 6.5446. So that means negative 1.945 is less than or equal to mu1 minus mu2, which is less than, just less than, not less than or equal to. .5446. So we would say we are 95% confident that the mean commute time for males is 6.5 minutes longer to 1.9 minutes shorter than the mean commute for females. And the results do agree because 0 is within the confidence interval. Now you will be completing example 2 on your own.